Dr. Esther Trufan, and in this experiment, I'm going to demonstrate what happens in a process called the common ion effect. For this experiment, we're going to need our saturated calcium hydroxide solution. And for common ion, we're going to use the calcium ion. So we are bringing in a soluble form of calcium, which is calcium chloride. We're going to make a solution that will utilize 2 grams of the calcium chloride, and the remaining of that solution will be our saturated calcium hydroxide solution. Because we're making a solution, we will be using a 100 milliliter volumetric flask. And as every other time, we're going to be careful to reach the mark and not exceed it, so we will adjust with a pipette. And to measure out the exact, or very close to it, 2 grams of calcium chloride, we're going to use a scale, a weighing boat, and a spatula. So let's get started with the weight measurement. We're going to turn on the scale, place the weighing boat on top, tare it, and then measure out 2 grams of the calcium chloride. I am using anhydrous calcium chloride, but should you use the calcium chloride dihydrate, you may want to adjust your mass measurements to reflect the 2 hydrates in your sample. My scale says I have exactly 2.00 grams of calcium chloride. Next, I am going to open up my volumetric flask, transfer the 2 grams of calcium chloride into it, and set my scale to the side. Next, I can add a small amount of my saturated calcium hydroxide solution in my weighing boat, just to rinse it through completely. And then I will begin adding small increments of the calcium hydroxide solution. The calcium chloride is almost fully dissolved. We need to continue swirling until it is fully dissolved. And what we are seeing already is a cloudiness emerging in the solution. Then we add more of our saturated calcium hydroxide solution. We swirl it some more. And then we add enough of the saturated calcium hydroxide solution to get us to the mark. When we are very close, we rely on our pipette to get us exactly there. Now we can close our volumetric flask and homogenize our mixture. We already notice that there is a cloudiness in this mixture that is likely indicative that there are solid particles forming inside what used to be a clear solution of the saturated calcium hydroxide. In order to test whether or not we are correct, we can always rely on the Tyndall effect and grab a laser pointer and direct it towards our solution. I have a laser pointer here, and I can aim it at the solution. And remember the rule, if it is a solution, meaning all the solid is fully dissolved, then it should appear completely clear, and we may see the 2 dots associated with the laser pointer on the glass, but we should not see it through the solution. But if there is solid suspended in the solution, then we should see the path of the laser beam. And here we very clearly see the path of the laser beam, meaning that we no longer have a solution or a homogeneous mixture. What we have here is very small suspended particles creating a heterogeneous mixture.